All right, here are your solutions for perfect problem 3 for Math 243. What we're going to be dealing with here is a distribution that tells us the weight of a fully grown black lab. And apparently it's approximately normally distributed with a mean of 60 and a standard deviation of 12. So what we know, maybe I'll start just stating these three things that we'll state on all these type of problems: the shape, the center, and the spread. Seems a little stupid right now, but as we get further on, you'll see that there's more of a justification for this stuff, so it'll be important to specify what's going on. But the shape, it tells us straight in the problem that's approximately normal. The center, we want to report the mean. Because it's approximately normal, because it's symmetric, the mean is our best measure of center. And in this case, the mean is given to us to be 60. And again, because it's roughly symmetric, the shape, the spread, measure of spread, we want to use the standard deviation, which was given to us to be 12. So we have this information and we want to answer a bunch of questions. What we'll need is a bunch of pictures of our normal distribution, which I will try to draw. There's one. And in the first part, it says that my dog, which is a black lab, weighs 56 pounds. And what we want to do is determine the proportion of black labs that weigh more than my dog. So in our picture, we got 60 in the middle, because that's the mean. And then we can kind of count out by 3 standard deviations. So if you go up 1 standard deviation, you get to 72. You go up another one, you'll get to 84. And up a third one, you'll get to 96. And similarly, if you go down 3 standard deviations, 60 minus 12 is 48. Minus 12 more is 36. And minus 12 more is 24. So we have this picture that looks more or less like this, and what we want to figure out is the proportion of dogs that weigh more than 56 pounds. So in my picture, 56 is somewhere in here. And so what we want to know is what is the area under the curve of everything to the right of 56. In other words, this shaded area here, it goes on forever to the right, but on the left it stops at 56. We want to know what is that area. And the good thing is our calculator can figure that out for us. It has a function designed to answer just this question. The function you use is normal CDF. Stands for normal cumulative distribution function. And the inputs you put into this function are first your left endpoint, 56 in this case, then your right endpoint. A little bit tricky, we don't have a right endpoint, so you can just put in any large number. You can use scientific notation to put in a huge number, but I find that, I don't know, 99.99 is plenty big, so I'll just use that. And then your mean, in this case 60, and your standard deviation, which is 12. So if I type all this stuff into my calculator, it'll give me the answer to this question. So the way I type it into my calculator to find this normal CDF function is under distributions here, which is above the variables key. So if I hit second and then variables, it gets me into distribution. And if I go down to normal CDF, I can just copy these inputs: 56, some large number, the center, and the spread, the mean and the standard deviation. If I hit enter, it'll give me this probability, this proportion. In this case, it's 0.63055. Maybe we'll call it 0.631. Or if you prefer percentages, it's 63.1%. So determine the proportion of black labs that weigh more than my dog. 63.1% percentage of fully grown black labs weigh more than my dog. We can do part 2 in kind of a similar fashion. It's the same idea. We have the exact same picture. So I'll sketch it maybe a little bit quicker. And therefore a little messier apparently. We got our mean is 60, and then we can go up and down by 3 standard deviations. I wish I knew how to just copy and paste this picture, or the red part of it anyways. And now that you have that drawn, we can answer another question. This time we want to know what's the probability that a randomly selected dog weighs more than my dog, but less than my brother's. So what you'll notice is that these two questions are worded a little bit differently what they're asking for. This area you can either interpret as the proportion of all dogs in this population that, in this case, weigh more than 56 pounds, or you can also interpret it to be the probability that one randomly selected dog will weigh more than 56 pounds. So I took advantage of that by asking two different questions, but really it's just the same question, a different way of wording it. Anyways, we want to know the probability the dog weighs between 56 and 94 pounds. Throw 56 over here, 94 somewhere over there. And then what I can do is shade in the area in between these two. And if I can find this area, the area of the shaded region, I'll have my answer. And as we saw in the last one, our calculator can do exactly that. It's just normal CDF, and then your lower end point, in this case 56, your upper end point, 94 in this case, your mean, and your standard deviation. And so you can type all that into your calculator. You could go into distributions again to find it. A little shortcut is if you hit second and then enter, it brings up the last entry you typed. So I can just take that last entry and I can delete a couple spots here and go from 56 to 94. So normal CDF, 56, 94, 60, 12. If I hit enter, I'll get 0.628. Or if you prefer percentages, 62.8%. That's the end of number 2. Got 2 more to do. Part 3. Part 3 asks a slightly different question. Still the same picture, which I'll sketch out real quick. Still got 60 in the middle. But now what it's saying is we don't know the value. We're not given this 56 here. We're given the answer, the proportion, the percentage. We want to find the value, the dog's weight, that would leave exactly 10% of the population above that point. In other words, there's some point out here, maybe I'll call it X naught. Should probably do that in green to be consistent. So there's some point, maybe I'll throw it out here, call it X naught. And what we know is that exactly 10% of the population lies above X naught. And it'll turn out we don't need to know what percentage of the population lies above X naught. We need to know what percentage of the population lies below X naught. But if 10% is above, 90% must be below. And once you know the proportion below, you can figure out the answer for what X naught is equal to. The way you do that is you use your inverse norm function. And the arguments for inverse norm is you tell it the area below, the mean, and the standard deviation. So if I punch this into a calculator, first of all, inverse norm is located under distributions, same place normal CDF was. It's the third thing on this list. And if I give it my 3 inputs, 0.9, 60, and 12, it'll tell me what dog weight I need so that that weight is more than 90% of the population, which answers our question. In this case, it's 75 point what? 0.4 maybe? So X naught is 75.4 pounds. A dog must weigh 75.4 pounds. Or I guess to answer the question, if a dog weighs more than 75.4 pounds, it's in the top 10% of all dogs in that breed and thus considered overweight. Finally, number 4. Same picture. You might note that I didn't make a bigger scale here. I didn't put the 72, 84, 96 because when I put X naught in, I didn't know what its value was. So if I didn't know where to put it, I guess is my point. I know it was bigger than the mean because only 10% was above it, but I didn't know how far left and right to go. So by leaving off the scale, it makes sure that I'm not wrong. Anyways, on number 4, it asks, it says a dog's weight is normal if it's in the middle 60% of the population. So what that's saying is maybe there's some value here and some value here. Let's try to make those a little bit more symmetric. Some value there and some value there. I'll call this one X naught, and I'll call this one negative X naught since we're using some symmetry here to get the middle. And this shaded area in here, I'm told, is supposed to be 60%. Don't confuse that with this 60 here. It's a complete coincidence. And as you may recall, our inverse norm function will tell us values that have certain proportions of the population below them. So if we want to figure out either of these values, we have to figure out how much of the population is below them. And the way we can do that is if 60% is in the middle, 40% is on the outside in total. So that means this must be 20% and this must be 20%. So we can figure out, I guess we could figure out negative x naught by doing inverse norm with 20%, or we can figure out positive x naught by doing inverse norm with 80%, because 80% is below here, 60 in green, 20 in blue. Anyways, let's do it. If I'll do this shortcut, copy that entry from last time, and put in a 0.8 here. And what that will give me is x naught, saying the dog's weight that has 80% of the population below it. And in this case, it's equal to 70.1 pounds. And then you can just kind of use some symmetry to find this other value. But I don't know if you, I guess it's just as easy to go back and do this again, except with a 0.2 instead of a 0.8, because only 20% is below this point. And what that tells you is 49.9 is my cutoff on this side. So to get the middle 60% of weights, it's dogs that weigh between 49.9 pounds and 70.1 pounds. And I guess I'm out of room, so I guess that's the end of this problem.